All right, everybody, welcome back to another episode of our Algebra 1 virtual tutor. And in this episode, we are going to look at objective 33. Now, the last few objectives have dealt with systems of equations. And in this one, we're going to talk about a system of inequalities. Luckily, when it comes to an inequality, the solutions are so different that there's not three different ways to solve these. The solution to a system of inequalities that we have there is a pair that's a solution to each system. The problem is you can have a bunch of different solutions because an inequality, think about what it says. If I say x is less than 5, that means the solution can be 4, 3, 2, 1. If it's x is less than or equal to 5, then it can be 5, 4, 3, 2. So we have all of these possible solutions that can work. It's not going to be a simple one coordinate. It's every coordinate that works. So that's why we say a solution, just singular. One of the solutions is a pair that works. But because there's so many, that the solution, so the graph of the system is the graph of all solutions. So you will only solve these graphically. You're not going to do elimination or substitution. Your graph is the answer. And we'll talk about what the graph looks like as we go into it. But step 1, graph each one and shade. And step 2 is to kind of highlight the solution region. Now, it's important to remember our inequalities here. I can have less than or greater than less than or greater than or equal to, less than or equal to. So what do I mean about all of these? I mean the shading's important as well as open versus closed circles. So probably the best thing to put here, I'm just trying to think of the easiest way to remember these. Let's go with y equals. And let's use an example here of 5. Rather than trying to give an abstract definition, let's just look at an example of this. So, what does it look like? I'll put a little graph here. All right, I'll put a little graph for each of these, and that way we can kind of see what's going on. All right, now each of these lines is going to be a horizontal line at 5. So what's the difference? Well, because these first two are just less than signs, that means these have to be dotted lines. Because these two are or equals to, these are solid lines. Now, that takes care of open versus closed. Now we need to take care of the shading. Well, this is a shade above because it's greater than. This is shaded below because it's less than. This is another less than. That's a greater than. All right, so let's look. Now, we were able to solve equations in our calculator. Inequalities, not so much. We're going to do these by hand, mainly because the shading, our calculator doesn't do a great job of shading these. And the whole point is to be able to shade this. So we're going to need them both into y equals. And we're going to graph both lines separately. Now, I find it's easier to highlight both equations with a different color so you can see which ones I'm graphing. So the first one in red starts at a y-intercept of 1, so I'm labeling my y-intercept. And then I'm going to go down 4 over 1. And I'm going to go the other way. and get as many points as I possibly can on my graph. Now, when I look at it, it's an or equals to, so that tells me that this is a solid line coming right through here. And we can kind of make these points a little bigger so our graph looks pretty good there. Okay. Now, my green equation starts at -2, so it was a y-intercept of -2, and it went down 1 over 1. So down 1 over 1. And again, get as many points as we can, even going the other way. The big key here is that my green one was a dotted line. There we go. Now, the shading is the challenge. I need to shade below the red line. So on every one of those points on the red line, I need to shade down, like so. I need to shade above the green line. So on every one of these points, I need to shade above. Well, a system of inequalities is only going to have 4 possible shaded areas. Think about how these would intersect. There's only going to be 1, 2, 3, whoops, that's all, 3, 4. So when we see which one do those shaded areas overlap, well, I kind of already did it. They overlap right here. And your solution is actually this shading here. It's only the part where the 2 areas overlap. All right. So let's look at a couple more. And we're going to follow that same basic pattern. You can see we're not trying to make this too challenging. All of these are already solved for y. Now, you could have some where you'd have to solve for y to begin with, but we won't get too much into that. Basically, we're after, let's make one of them red, and let's go blue this time. And let's go ahead and graph these. So my red one's going to start at -2 and has a slope of -1. So you can see I'm taking care, get as many points on these lines as possible, just like graphing a regular linear equation. And it's a solid line, like so. My blue line's going to start at 3, and it's also going to go down now. Uh-oh. These lines are parallel. That's okay. Now, in equality, this is going to be dotted. When we solved a system of linear equations, this would have been no solution because they don't cross. In this case, we're only concerned with the shading. So this is not going to be a no solution until I confirm where the shading is. So on the red line, I need to shade above. So I kind of make a little note where I'm shading above. And on the blue line, I need to shade below. So where do those 2 overlap? They overlap right in the middle. Like so. All right. Let's look a little farther. And I'm going to start at -3. And I'm going to go down 2 over 1. And I'm going to go backwards. There we go. And this is a dotted line. There we go. My blue line, it's going to start at 2, or 1, sorry. And it's going to go up 2 over 1. And this is a solid line. Okay, now, my shading, they are both less than. So I need to shade less than the blue line and less than the red line. So my area is right in here. And we can shade it in even better than I have been before and kind of do that. So really we're taking what we've kind of already done back in the day and just putting two systems together. All right. Well, let's do 2 at 1 here, just to kind of color code this a little easier. Again, you don't need to color code this, but for the interest of following along to my video, it's a little easier here. All right, so the red line in number 3 is going to go down 3 over 2. Up 3, left 2. And this will be a dotted line, like so. All right, my blue line's going to start at -3. And it's a slope of 1 over 1, and this is a dotted line as well. All right, now my shading. Again, there's only one of 4 areas. 1, 2, 3, 4. It has to be one of those areas. So let's go ahead. It is above the red line, so think about what happens there. It's above this, so that eliminates both of those areas. That's what's going through in my head as I'm doing these. Now, I don't want to actually label that, but that's what's happening. Now, it also, let me get rid of that arrow too, is above this line, so that eliminates both of these areas. This one was already eliminated before, so you can see I'm left with this right here. So we get rid of all of that. That's just our thinking. But this is the shaded area. And there's really no way to make shading look good. You guys will have a better time because you'll have a pencil. It'll be a little easier to shade. All right, last one. All right, the red line starts at a y-intercept of 1 and goes down to over 1. Up to left 1. Again, make sure you're getting as many points as possible on those lines. And you can always kind of double up on your line just to make sure it's nice and even. Or, you know, you could use a ruler and make it even better. Down 1 over 2 for my blue line. And backwards. All right, and this is dotted, like so. And now my shading is above both of those lines. So it's going to be right through here, like so. And again, this doesn't need to be perfect. You do the best you can. All right, so your answer to the solution of a system of inequalities, you can see, is simply the graph. Now, I might ask you to go one step farther and say identify a point in the solution area, or which of the following is a solution. And then you'd have a bunch of points and you'd have to pick which point is in the shaded. Like this point would be not a solution. This point would be. This point would be because it's on the line. This point would not be because it's on a shaded line or a dotted line. So it could ask you to do all of that too. All right, so whoops. Let's not do that. Hang on. Okay. There we go. Sorry about that. All right, so hopefully you found this video useful. And again, feel free to go back to it as you need. Hopefully we'll see you at the next one.